I have to start today with the number that came out of the research packet this week. It's one of those statistics that makes you just stop scrolling, stop sipping your coffee, and actually pay attention. The source material claims that up to 90% of cancers might be preventable.
It is a massive number. It honestly sounds like a typo when you first read it.
It does. It really does.
Yeah.
It's almost hard to process because I think, most of us operate under this default narrative that cancer is essentially a lottery.
Right, like a roll of the dice.
Exactly. It's bad luck or it's bad genes. You just hope your number doesn't come up, but you don't really feel like you have a hand on the wheel. But if 90% is preventable, that suggests we've been looking at the problem completely upside down.
Completely upside down. And that statistic is really the anchor for this entire deep dive. We tend to view cancer as a genetic inevitability, something just written in stone at birth. And while genetics certainly play a role, the research we're looking at today suggests that genes are more like a loaded gun. They have the potential to fire, but they don't pull the trigger themselves.
So the environment, specifically the internal environment of our bodies, is the finger on the trigger.
Yes, exactly. And this brings us to the core concept of today's session, which is nutritional epigenetics.
Which sounds incredibly academic. I feel like I need a lab coat just to say it.
It does sound a bit dense, yeah. But the principle is actually quite beautiful and simple. Epigenetics basically means above genetics. It's the study of how your behaviors and your environment can cause changes that affect the way your genes work. The big takeaway here is that food isn't just fuel.
Right. We usually just think of it as calories.
Exactly. Calories or energy. But biologically, food is information.
Information. So I'm not just filling the tank. I'm writing code.
Yes. Every bite sends a specific set of instructions to your cells. You are constantly coding your own biology. The sources we're analyzing today, including some really compelling work from Dr. Amy, who is a cancer researcher and survivor, they argue that cancer is fundamentally a metabolic disease.
Okay, let's pause there for a second. Metabolic disease. Usually when I hear that, I immediately think of diabetes or obesity. I don't really think of tumors. How are we applying that term to cancer?
Well, think about what metabolism is at its most basic level. It's how your body processes energy. The argument here is that cancer cells have a very specific warped metabolism. They process energy differently than healthy cells do. And this is the crucial part. They require a specific metabolic environment to thrive.
So they can't just grow anywhere?
No, they need the right soil. Our mission today is to figure out how to build an environment where those cells essentially starve or go dormant rather than exploding into growth.
So we're trying to understand the architecture of a cancer-proof body.
Mm-hmm.
Or, at least a cancer-resistant one.
We want to understand the blueprints. You want to know what materials we need to build a structure that doesn't just collapse when stress hits it.
All right, let's look at the enemy first then. If this is a metabolic issue, what does a cancer cell actually look like in terms of behavior? Because I usually just picture a blob that grows too fast.
The most helpful analogy from the texts is to think of a cancer cell as an inefficient engine.
Inefficient how? Like a gas guzzler.
Yeah, exactly. A healthy cell is like a hybrid car. It uses oxygen efficiently to generate power. It's clean, it's balanced, it creates very little waste. A cancer cell is like an old muscle car with a fuel leak.
Oh.
It is incredibly needy. It burns through fuel rapidly and creates a lot of dirty exhaust, specifically lactic acid, and its fuel of choice is glucose, sugar.
So they are energy hogs.
Massive energy hogs. They have a voracious appetite for sugar, far more than healthy cells do. But here's the catch, and this is why the environment matters so much. This inefficient engine doesn't just grow in a vacuum. It needs infrastructure.
Infrastructure, like roads.
Exactly like roads. It needs a supply line. In the research, this is discussed as angiogenesis. As a tumor grows, it effectively hijacks the body's circulatory system. It sends out chemical signals that trick the body into building new blood vessels directly to the tumor.
Just to deliver the massive amount of oxygen and nutrients it needs to sustain that rapid growth.
It's dactyly.
It's building its own highway system. That's actually kind of terrifyingly smart.
It is. But the environment we create in our bodies can either help pave those roads or it can put up roadblocks. The sources identify 4 main conditions that cancer loves 4 pillars that support this construction project: high blood sugar, constant growth signals, chronic inflammation, and a weakened immune system.
Okay, so if those are the 4 pillars of a cancer-friendly environment, let's break down how we might be accidentally building them. I want to get into the specific culprits mentioned in the notes. And the first one seems to be the heavy hitter, the signal spikers.
Yes. This is where we have to talk about sugar and insulin.
Now, we established that cancer loves sugar as fuel. But you mentioned signals earlier. Is this just about feeding the beast, or is there more to it?
It's both. And the signaling part is actually more dangerous than the fuel part. When you consume what the source calls liquid sugar, sodas, sweet teas, energy drinks, those fancy coffee drinks that are basically milkshakes, you aren't just dumping fuel into the tank, you are slamming down on the accelerator.
Why is liquid sugar singled out, though? Is a Coke really that much worse than a cookie? Sugar is sugar, right?
Biologically, no. The delivery mechanism matters a ton. When you eat a cookie, there's usually some fat or flour, maybe a tiny bit of fiber, if you're lucky, something to slow down digestion slightly. Liquid sugar hits your bloodstream almost instantly.
Because there's nothing to break down.
Right. There is no matrix to hold it back. There's no fullness signal. So you can consume a massive amount of glucose before your brain even registers that you've eaten.
Right. You can drink 50 grams of sugar in 3 minutes and feel absolutely nothing. If you tried to eat 5 apples in 3 minutes, your jaw would get tired.
Exactly. So your blood sugar spikes dramatically.
Yeah.
Your pancreas panics and floods your system with insulin to get that sugar out of the blood. But here is the mechanism that people miss. High insulin triggers the release of another hormone called IGF-1.
Insulin-like growth factor 1.
Correct. Now, context is key here. In a growing child, or if you are recovering from major surgery, IGF-1 is essential. It tells cells to reproduce and grow. But as a healthy adult, having high levels of IGF-1 floating around chronically is dangerous. You are essentially grabbing a megaphone and shouting, "Grow," to every cell in your body.
And if you have a precancerous cell, one of the inefficient engines lying dormant, you just woke it up.
You just gave it the green light. The source calls this the perfect storm. You have provided the abundant fuel, the glucose, and the command to use it, the insulin and IGF-1.
That's a very vivid image. It's not just feeding the fire, it's pouring gas on it and fanning the flames at the same time.
And it's about frequency, too. If you do this once a month, your body has checks and balances to handle it. But if you're spiking your insulin 3, 4, 5 times a day, you are keeping your body in a chronic state of growth mode. You never give the system a chance to rest, repair, or clean house.
Okay, so step 1 in our architectural plan is stop shouting grow. Let's move to culprit number 2. This feels like it addresses the soil of the environment. The sources call it the inflammation factory.
Right. And the primary driver here is processed food.
I always feel like processed food is a bit of a buzzword. It gets thrown around so much it almost loses meaning. How are our sources defining it? Because technically, cooked carrots are processed.
It's a fair point. In this context, we aren't talking about cheese or yogurt or cooked vegetables. We are talking about ultra-processed foods. These are industrial food products, things with long shelf lives, vibrant packaging, and ingredient lists that look like chemistry experiments. They are engineered to be hyperpalatable, meaning they bypass your satiety signals entirely.
The middle aisles of the grocery store, the stuff that never goes bad.
Generally, yes. And the danger here is twofold. First, it's what these foods contain. Second, it's what they replace. Let's look at the contents first, specifically sodium.
Salt. I thought salt was mostly a blood pressure concern. Watch your sodium or your heart will explode.
That's the common knowledge, sure. But in the context of cancer architecture, sodium acts as a persistent irritant. The research shows a strong link between high sodium intake and gastric cancers because salt can physically damage the protective lining of the stomach.
It's corrosive.
In high chronic amounts, yes. It causes cell turnover and inflammation. But it also disrupts the microbiome, the trillions of bacteria in your gut. We know now that a huge portion of your immune system actually lives in your gut. When you bombard that ecosystem with preservatives, high salt, and emulsifiers, you create a state of dysbiosis, an imbalance, and that leads to systemic inflammation.
And cancer thrives on inflammation.
It loves it. Think about what inflammation is. It's the body's emergency response. It involves increased blood flow, cell division, and tissue repair. That is the perfect cover for a cancer cell to hide in and multiply. It's like a criminal hiding in a riot.
That makes a lot of sense. So that's the damage caused by what's in the food.
Right.
You mentioned the second factor is what these foods replace, the crowding out effect.
This is arguably just as important. If you fill up on chips, crackers, or instant noodles, you physically do not have room in your stomach for broccoli, berries, lentils, or nuts. You are crowding out the protective foods.
It's an opportunity cost.
Right.
Every bite of junk is a missed opportunity for medicine.
Exactly. And the biggest casualty is fiber.
Fiber, the absolute most unsexy nutrient in existence. Everyone knows they need it. Nobody wants to talk about it.
It really is the wallflower of nutrition, but it's the unsung hero of cancer prevention. Fiber does 3 critical things. 1, it acts as a buffer for sugar. It blunts that blood sugar spike we talked about earlier. So it helps with culprit number 1.
Okay, that's huge.
2, it feeds the good bacteria in your gut, which produces short-chain fatty acids that actively lower inflammation. And 3, it physically helps remove toxins from the digestive tract. It binds to them and escorts them out.
So when you live on a diet of processed food, You're hitting yourself from both sides, you're adding the inflammatory agents, and you're actively removing the fire extinguishers.
Precisely. You are building a house with flammable materials and then firing the fire department.
Okay, so we've covered signals, the sugar, and soil, the inflammation. Now we need to talk about culprit number 3. And I have to say, reading the notes on this one was a bit of a bummer because it attacks some of the great joys of summer. We have to talk about direct DNA damage.
Yeah, this is the part where we usually lose the live little crowd. We're talking about char and alcohol.
Let's start with the char, because the source was very specific about the chemistry of the barbecue. I love a good sear on a steak, but apparently my cells do not.
It is simple chemistry, unfortunately. When you cook muscle meat, beef, pork, chicken, fish at very high temperatures, like grilling or pan frying, proteins and sugars react to form new compounds, specifically heterocyclic amines and polycyclic aromatic hydrocarbons.
Which sounds like something you'd find in a tailpipe.
Actually, you do find them in car exhaust and cigarette smoke. That blackened, charred crust on a steak. That is concentrated DNA-damaging material.
So when we eat that, we aren't just dealing with calories or fat. We are introducing compounds that physically interact with our genetic code.
Yes. These compounds can bind to DNA and cause mutations. And remember, cancer starts with a mutation, a copying error. By eating heavily charred foods regularly, you are increasing the rate of those errors.
Okay. I can scrape the black stuff off my toast or my burger. I can live with that. But the alcohol section, the sources were pretty uncompromising here.
They were, and this is a massive shift in the medical consensus over the last decade. We used to think a little bit was fine, maybe even healthy, but the cancer data is clear. Alcohol is classified as a group 1 carcinogen.
That is the same category as asbestos and tobacco. It feels extreme.
It feels extreme because alcohol is so culturally embedded, but biologically, the classification is solid. It is linked to at least 11 types of cancer, including breast, colon, and liver. And what's fascinating in a dark way is how it works. The source describes alcohol as a solvent.
A solvent, like paint thinner.
Think about what a solvent does in a chemistry lab. It dissolves barriers. It increases permeability. When you drink alcohol, specifically in the mouth, throat, and esophagus, it acts as a solvent that makes your tissues more permeable to other carcinogens.
Whoa, so if I'm eating that charred burger and drinking a beer...
The alcohol is essentially holding the door open for the chemicals from the char to enter your cells more easily. You are amplifying the risk.
That's incredibly specific and disturbing.
It gets worse. When your body breaks down alcohol, it turns into acetaldehyde, which is directly toxic to DNA. It smashes up the genetic code. And this is the kicker. Alcohol depletes the very nutrients your body needs to repair that DNA, like folate.
So it breaks the window, lets the burglars in, and then cuts the phone line to the police.
That is a very accurate metaphor, and the source is clear that this is dose-dependent. The more you drink, the higher the risk. There isn't really a biological safe floor for cancer risk when it comes to alcohol.
This is starting to feel a little bleak. I mean, we've got sugar shouting grow, processed food causing inflammation, and the barbecue and beer smashing up our DNA. It feels like the modern world is designed to give us cancer. Do we have any defense? Or are we just sitting ducks waiting for a mutation?
We are absolutely not sitting ducks. This is where we pivot to the hopeful part of the architecture. You have a built-in defense system. It's called immune surveillance.
Immune surveillance. It sounds like a security detail.
It is exactly that. Here's a fact that offers a lot of perspective. You, me, everyone listening, we are all producing abnormal cells right now.
Wait, really? Right now?
Yes. You have billions of cells dividing every day. It's a messy process. Typographical errors happen, mutations happen, but a mutation is not cancer. Cancer is the survival and spread of that mutation. In a healthy body, your immune system, specifically things like natural killer cells, are constantly patrolling. They spot an inefficient engine it doesn't belong, and they eliminate it.
So the goal isn't to never have a mutation, because that's impossible. The goal is to keep the security team awake and armed.
Exactly. And this connects everything we've just discussed. Why does the security team fail? Because we sabotage it.
High sugar distracts them.
High sugar spikes insulin, which can suppress immune function. Alcohol directly damages immune cells. Lack of fiber means the headquarters of the immune system is weak. When you live that perfect storm lifestyle, you are effectively cutting the budget for your security detail while simultaneously inviting vandals into the building.
That framing actually makes this feel manageable. It's not about bad luck. It's about resource allocation. If I stop wasting my body's energy on fighting inflammation and processing alcohol, it has more energy to hunt down these mutations.
It puts the ball entirely back in your court.
But let's be real for a second. We've listed sugar, salt, alcohol, and grilling. That's a Friday night for most people. I can hear the listener thinking, do I have to live like a monk to be safe? Because frankly, I'm not going to live like a monk.
The source material addresses this head on, and I'm really glad they did. This is not about perfection. It is not about moralizing food. You don't get cancer because you had a slice of cake at a wedding.
Thank goodness for that.
It's about patterns over time. Cancer is a slow-moving process. It takes years, sometimes decades, to develop. It thrives on chronic conditions, not acute ones.
So it's about the default mode. What are you doing 80 or 90% of the time?
Exactly. It's about being strategic. If you understand the architecture, you can make trade-offs.
Give me an example of a trade-off. How do I apply this to real life?
Okay, let's say you're going to a barbecue this weekend. You want the steak. Fine. But knowing what we know, maybe you skip the sugary marinade to avoid the char-sugar combo. That lowers the formation of those nasty compounds.
Okay, that's easy enough.
And maybe you load up your plate with a massive salad, first getting that fiber in to help your body process the meal and buffer the digestion.
So you're creating a buffer.
Right, and maybe you swap the beer for sparkling water with lime. You're still enjoying the event, you're still eating the steak, but you aren't spiking your insulin and introducing a solvent and eating carcinogens all at once. You're breaking up the perfect storm.
It's about breaking the circuit. You don't have to be perfect, you just have to stop the compounding effect.
Correct. The source uses the phrase, don't feel fear, feel awareness. Fear is paralyzing. It makes you want to ignore the problem entirely. Awareness is actionable. You eat 3, maybe 4 times a day. That is over 1,000 opportunities a year to vote for the kind of environment you want inside your body.
That's a powerful way to look at it. You are the architect. You can't change the genetic blueprints you were born with, but you are the one ordering the materials every single day.
And the materials determine the structure.
So we've thrown a lot of science at everyone today. Nutritional epigenetics, angiogenesis, IGF-1, solvents, but it really boils down to that internal conversation.
It does. It's all about communication.
I want to leave the listener with this thought, based on what we've learned. If food is information, what are you telling your cells right now?
That is the ultimate question.
Are you shouting grow at them with liquid sugared inflammation? Are you confusing them? Or are you whispering repair, protect, and defend with fiber and whole foods?
The answer is on your plate.
Simple as that. If you want to dive deeper into the visuals for all this, there is a fantastic video from Dr. Amy in the show notes that breaks down the inefficient engine concept with some great animations. It's definitely worth a watch to cement these ideas. But before you do that, maybe just think about what conversation you want to have with your body at your next meal.
Highly recommended.
Thanks for diving deep with us. We'll see you in the next one.